Yep, I can see it.
All right. So, like I was saying before, there is a way to like chat and stuff like that, and I might see it pop up. There's like a chat thing you can do. But if I'm over here on like this screen, I might not see it. I'm not sure. So if you do have a question, probably the best thing to do is just unmute yourself and shout out, interrupt me, whatever. It'll all work out. But otherwise, keep your mic muted. That way we're not getting tons of feedback. If you do start getting some weird performance issues, bandwidth issues, one thing you might try to do is turn your video feed off. Not that we don't all want to see each other, but that's taking up extra bandwidth. So depending on what your internet connection is, that may or may not be helpful for you. So those are some things to try. But in any case, as you likely have heard, the university is closing. Well, it's not closing down. So I'll tell you what I know, and if you have any questions, I'll answer them, and then we'll dive into our keep going with our stuff. So I guess like a lot of other universities, what we're doing is the goal is to minimize the amount of direct big group contact. So in case there's one person who's infected in a room, they don't get another 30 people infected. So the idea is if anytime we can move to a less crowded environment, that's a preferred thing right now. The hope is that a month from now we look back and say that this was an overreaction and we likely didn't have to do it in hindsight, but it's probably the right call to do now. Just better safe than sorry type thing. Good news is we have spring break coming in next week. Your other faculty, I mean, the CS faculty should already be pretty well versed at dealing with online stuff. We've teach students over in Ann Arbor, so we already have plenty of people dealing with this. So from our perspective, things aren't going to necessarily change, other than the fact that maybe you'll actually be able to see my screen better than those of you who are in like the back. Looking at the TVs, you might be able to see my code a little bit better just looking at it on your personal screen. But I'll still record, I'll still upload it to YouTube. All of our classes will still be in real time, just like we were in the normal classroom, except we'll be face-to-face on Zoom, virtually face-to-face. All of your other teachers should have already contacted you. If they haven't, you might want to reach out to them just to see what their plan is. So we were told to contact all of our students, and I was part of the original group helping make the global decision, so I knew about it a little bit early. So I was probably the first one who contacted all of you. But by now, all your teachers should have contacted you about what to expect when you come back from break, whether that's an email or they spoke to you in class this week. I'm mainly running our thing in class, a thing via Zoom today to make sure everybody has the technology up and running and has any questions. I am on campus today, so if you are here and need to come by and get some technology debugging or something like that, I'm happy to help. As we move forward, I guess one word of warning, specifically to the college audience like this is, you guys are in pretty good shape from a getting the virus and recovering from the virus perspective, but try to be conscious about going someplace, possibly having some symptoms, and then infecting others, especially older folks. So you guys are kind of like the worst case scenario for like a nursing home or something like that. So try to be aware that your sickness could impact others, even though from a health perspective, you guys are individually probably in pretty good shape. So just keep that in mind as we start going through, and obviously the number of cases are probably going to go up, and hopefully these precautions end up getting us past the crisis fairly quickly, and everything will learn something, and maybe our medical practices and stuff will improve from having to deal with this type of thing. So all of our classes will be using the same Zoom link. So we'll call this my public classroom. So, you can save this link somewhere, so you can just click the same link every single time. I know several of you work in study groups. If you want, I can create a link for you for your study groups. Just send me a message on Zoom with the people that are in your group. And then I'll create that group and set you all as moderators so that you can have your own little group to get together and be able to share stuff, things like that. There's a way to do like breakout rooms and stuff like that. But as moderator, you get a little bit better, more power with the system. So feel free to ask me to do that so you guys can still maintain your study groups. And again, it might even be better than, if somebody can share their screen, you can see their code rather than having to shoulder surf and see what they're typing. So other cool things you can do if you haven't used Zoom a lot is you can control somebody else's computer. So sometimes I'll meet with somebody over Zoom and I'll be helping them debug their code, and I can actually remote into their machine using Zoom and control their mouse and keyboard and stuff like that to help them debug. So there's lots of pretty cool tools where hopefully for computer science, the Zoom experience is not necessarily a step backwards. In fact, there's probably some legitimate perks to it. There's going to be some challenges in some of your other classes potentially. I can't even imagine how like an art class or like a pottery class or something like that might run. So, if you have some good suggestions for your teachers, I would encourage you to maybe, I would say good constructive suggestions for your teachers, reach out. Obviously this is a inconvenience for everybody involved. So, keep in mind that, we're all kind of dealing with the same thing, and this wasn't any of our choices. So, let's try to make it as successful as possible. And then hopefully we're back in the physical classroom as soon as the middle of April. I believe the email to the students kind of indicated that, so next week's spring break, the reason they say classes starting next Monday are going online is because the pharmacy school is on a different schedule. So they're actually still on campus next week. Their spring break was either this week or is in 2 weeks, something like that. It's one or the other. It's not next week. So for all of you, next week is still your official spring break. We won't have any classes next week, but when you come back, our classes will remain online. As of right now, the university is supposed to stay up and running, and I'll be on campus most days. The dorms are going to be open as of right now, but I do think since you're not going to have face-to-face classes, they're encouraging students to not come back unless this is their best option for living. I mean, if you live far away or it's not you work locally, whatever it is, if living on campus is what you need to do, the dorms are going to be available. But if you don't have to be here, they're encouraging you not to be here just from a safety perspective, but they are available. All right, so I think that's kind of what I know. So does anybody have any questions or clarifications? And I'll tell you what I know, and then we'll jump back into Python stuff.
I have a question. Will you have the link ready to be available on Blackboard?
You mean the link for Zoom?
Yeah.
I can put it up there.
Okay.
Yeah, I'll just put it.
Because what I'm thinking of is creating a document that will have all the links that I can easily access my classes through Zoom.
Okay.
All right. Thank you.
Could you possibly put it on Slack as well?
It's up on Slack.
Oh, okay. Thank you.
It was on the original email. It's in your email too. So it was on the original email I sent. It was on the original Slack message I sent. I just pasted it again, 15 minutes ago. So it should be right at the bottom of the channel on CSC200 in Slack. And that link's not going to change for my classroom. So that's a hard-coded recurring meeting. So there won't be a new meeting link per class. You can bank on that being our class for the immediate future.
All right, thanks.
And like I said, if you any of you want to have a your own study group room, let me know and I can create a Zoom link just for you. Otherwise you can always come in and use this room if you want, just like you can use the classroom, S1 or S118, our normal classroom. But if another class part is in, you're going to be displaced. So if you do have a study group, I'd encourage you just to message me. I'll create you a Zoom room. It doesn't cost me anything, and it takes like a minute. So and I'll send you a link, and you can just distribute it to your study group members. So in any case, just do that on Slack or email, one of the two, but Slack is probably the quickest. All right, other questions? All right, so one other, I guess the last thing I'll say before we jump back in is make sure you are checking email and Slack often. Because we're going to still keep using Slack the way we used it before. I will put announcements up on CSC200. I do try to, for important announcements, also send an email and put it as a course announcement. But I shouldn't have to do that. You guys should be regularly checking Slack, or at least setting up a notifications for the CSC200 channel, at least. So you get those announcements. If you did notice last week, I also created a couple of new channels. One's like student, here, let me just bounce over here real quick. Student opportunities and also internships. So you can join either one of those channels. You might have to go like add the channel and find it, or search for the channel, wherever it is. There's like a search thing. But one's called internships and one's called student opportunities. So you might want to set up your notifications for those as well. I had been putting some of those stuff in general, but I know people don't like to set up notifications for general. So things that are specifically targeted at, student development, like internship opportunities or conferences, things like that, that are coming up that, we're giving you opportunities to get involved with. I'll post in those channels so you can be a little bit more directed with your notifications. All right. But really up the amount of time you're checking Slack and things like that, or at least through notifications. It sends you a push notification right to your phone. Put Slack on your devices. It works just like text messaging. It's a very, very, very good tool, and it works when when I can rely on everybody else using it. All right. So, if we just look at today's class in particularly, we have approximately 10 people who either missed the message. I presume they wouldn't have skipped class anyways. So they were not reading Slack or their email or the Blackboard announcement. So make sure you are checking those things. And if you have friends from class who are not currently in here, give them a hard time about checking those things as well. It's going to be extra important, not just for my classes, but for all of your classes moving forward. All right, anything else? Okay, so then let's keep trucking and kind of get through our overview of objects, because we're going to hit those pretty hard post break. So I want to, our goal this week is to kind of catch up on things and also bring a lot of stuff together, kind of connecting some dots that are, have been sitting out there waiting for the next shoe to drop. So I want to try to bring those things together. So, last class we were kind of talking about, reminding ourselves about dictionaries and kind of what they are, their weaknesses, and their benefits. I mean, a dictionary is a perfectly good tool. It holds a collection of name-value pairs, so it can store lots of pieces of information about stuff inside of a dictionary. And I think we had an example. Go away. Did I do it in? Oh, here, let me just cut this out here. So for instance, I could create a fraction as a dictionary and say something like numerator is 1, denominator is 2, And then I can go ahead and say, oh, that's the fraction 1/2. And operate on those things. And I can write functions that will go and, you know, print out this thing. Because if I just print fraction right now, you know, I get this format that looks like a dictionary. But if I go ahead and write a quick function like print fraction, and this guy takes in a fraction dictionary as a parameter, as input, I can then go ahead and say something like print. We'll do the first one, so we'll say fraction dictionary at bucket numerator. Concatenated with maybe a slash. Concatenated with fraction dictionary at bucket denominator. Keeping in mind, I'll put my closing parenthesis here, keeping in mind that the value of fraction at bucket numerator is a number. So I actually need to convert that guy to a string in order for concatenation to work. So now I can call my print fraction function, giving it my fraction. And notice I get a much prettier output for my fraction. So I've taught this function how to, given a dictionary representation of a fraction, display it in a clean way, let's say, rather than the traditional, this is how dictionaries look when we print them out. Okay, so dictionaries are powerful tools in that they are allow us to represent multiple pieces of information inside of a single variable. So we don't want to discount that. But they do start having issues even if we just look at this. And I know we've talked about this already, but I just want to review it, really drive this point home, is if I just decided that I can represent fractions like this, if I want to operate on a fraction formatted like that, I have to write a bunch of functions external to that dictionary. These are just fractions that live out, functions that live out in the world that I can pass something in this format to that it will operate on. As opposed to, oh, we actually had already written a fraction dictionary up there. So that's fine. So as opposed to, we can create a class for a fraction, and we're going to talk about constructors here in a few minutes, where this guy takes in a numerator and a denominator, and then we can ask that fraction to display itself. So now I can do something like f1 is equal to fraction 1/2, and say f1 dot display. And see, we get the same output visually, but I actually created an instance of the fraction class with a numerator of 1 and a denominator of 2. Numerator of 1, denominator of 2, because they took in these two parameters. And then I asked that fraction to call his display method. And his display method lives inside the fraction class. So rather than having these disjointed things where I have, you know, I just haphazardly decided to represent fractions this way, and then in order to operate on those, I have to write a whole bunch of functions to just live out in the middle of nowhere, I can now package everything up in this nice container called a class, where I'm able to conveniently build a fraction with whatever inputs make sense for that object. So in this case, it's a numerator and denominator. I'm able to display it, and I can also do some other things. We'll add some stuff to that today. All right, so getting back to the slide here, we see dictionaries along with functions allow us to accomplish a lot of stuff, but we can create this container called a class that can bring all those things together into a single container, being more organized, that we can then pass that container around and accomplish stuff. All right, so we say a class is a collection of class members, where class members are fields, constructors, and then functions. In object-oriented programming, functions are typically referred to as methods. Fields are the variables associated with this class. Sometimes these are called attributes. Constructor is a special function that initializes, or you can say initially builds, this instance of the object. So kind of connecting that dots to a real example, if I go over here, here's my constructor for fraction. Notice it has this very special name, underscore, underscore, init, underscore, underscore. Constructors must be called that. That's the name of it in Python. All right. You can actually have multiple constructors, but for right now, we're just going to assume we only have one constructor. So we have a constructor named init. Don't worry about this first parameter yet. For right now, just assume you always have to at least pass a parameter called self. It's the way object-oriented programming is implemented in Python. Let that be good enough for now. We'll talk more about that. All right, so ignore this first part. Just assume it's part of the syntax. All right, notice that display also took that same parameter. So all of your functions that live in here will take that same parameter. Okay, so our constructor here is expecting two pieces of information. In order to construct a fraction, we must be given a numerator and a denominator. And what we will do is we will set this fraction's numerator equal to the fraction or the numerator that was passed in, and this fraction's denominator equal to the denominator that was passed in. All right, so we're providing two pieces of information to this constructor, and this constructor, he's decided that the way he will initialize this particular kind of object, in this case it's a fraction, is he will set the two fields of this fraction, the numerator and the denominator field, equal to the two parameters that were passed in. All right, so the job of a constructor is to initialize the value, the variable. So this guy right here is what gets called when I do this line right here. So I'm saying I have a variable named f1, and I want this to be equal to a fraction. So when I call the fraction class here, passing it two parameters, what it's actually automatically doing, so we'll put a little comment here. What's the comment? This guy? This guy. This calls the underscore underscore init method of fraction. So notice I'm passing in two numbers here. Notice that underscore underscore init takes in two numbers, and he will do something with those numbers. In this case, he sets his own fields equal to the values that were passed in. So self.numerator is this particular fraction's numerator. So if I come down here and I say print f1 dot numerator, we see I get the 1. If I say print f1 dot denominator, we'll see I get the 2. If I create a second fraction, so just like if you went out and bought a second cell phone, it's a distinctly different cell phone, even though it might perform the identical functions of the first one. So I'm going to build a second fraction, and this guy might be 3/4. So now if I were to print out f2's numerator and denominator, notice I get the 3 and the 4. Okay, so fields belong to an individual instance of a class. F1 is said to be an instance of the fraction class. He has his own fields. F2 is said to be an instance of the fraction class who has his own fields. They both have fields with the same names in them. They both have a numerator and a denominator field, but F1's numerator is a 1 and his denominator is a 2. F2's numerator is a 3 and his denominator is a 4. Okay, so understand this gives us a lot of power because we can house all of our logic, this is the dictionary feature of a class, that it can hold a bunch of name value pairs. And then this is the function feature of a class where we can put functions inside of that class. We can embed them in the class. So this guy is kind of this self-sustaining thing, as opposed to if you think about your smartphone being like a dictionary. If you want to make a phone call, you'd have to go somewhere and like plug your smartphone in, and that uses the computer inside your smartphone to make a phone call. That would be inconvenient for us. We kind of expect that our smartphones have all those features and stuff built inside of it, and we have this nice convenient carrying case that we can just throw in our pocket and it can do all sorts of stuff. All right, that's the power that a class gives us. This is the power of object-oriented programming. We create objects that can be initialized with some fields, and then they can potentially perform other operations. All right, any questions on that? Okay, and I really am trying to drive this point home. I mean, all the exams are graded now, but there was, and actually I didn't point it out, but the exams were actually as a whole quite good. I think the class average was a 70 or 72 or something like that. But if I go from the historic first exam performance, this class is doing better than most classes, which I guess was good to see, since I haven't been very happy with the book and kind of regret going down that path, but I can't time travel, so we'll just fix it moving forward. But in any case, the exams were pretty good. If you got a 70 plus or something on the exam, you're probably right where you need to be. Some people who got kind of grades more in the middle, it was interesting. I think the most missed question on the exam, one of them was, what does it mean for Python to be loosely typed and interpreted? So loosely typed means that when you define a variable, you don't have to define what kind of value this variable is built for holding, which makes Python a little bit inconvenient. I'm naming this value numerator and I'm naming this parameter denominator, and we can use human logic and say, okay, well, the numerator for a fraction is numeric. The denominator for a fraction is numeric. So because this person named these guys well, he probably wants me to pass in two numbers. But nothing keeps me from saying F3 is equal to fraction hello world. It's perfectly legal. And then I can say F3.display, and there's my fraction hello world. Okay, we're not going to be real successful if we start trying to add fractions together and stuff like that if we have strings in there. So Python doesn't give us the ability, because it's a loosely typed language, it doesn't allow us to specify what kind of value we expect here. With that in mind, we get a lot of flexibility, which I actually think is bad for beginning programmers. I think if I had my druthers, we would probably teach a different language for the first language, and then Python being a more advanced language, even though we typically flip-flop those two. We think of Python as an easy language to learn. I'd rather, if we think about this like the movie The Matrix, I'd rather kind of give you some well-defined rules that get, where you get beat up a little bit if you break them, as opposed to Python lets you get away with some stuff that it's not really great programming practice. But in any case, that's the scoop. So Python being loosely typed means we don't have to give types. In fact, we're not allowed to give a type of value that these variables are built to hold, where in like Java, we would have said this is an int numerator and this is an int denominator. We specify the kind of value it's built to hold. So that's the loosely typedness of Python, as opposed to the interpreted aspect of Python has to do with when does the language get converted to low-level code. A compiled language like C++, it gets compiled prior to us running the program. So it's running directly on the CPU right away. Whereas an interpreted language like Python, it gets converted into the low-level code to run on the CPU while it's running, during runtime. So you probably should have said something about it being relatively slow, and then the loosely typed is you don't have to define the kinds of values we hold in variables. The interpreted part is when it's relatively slow because it actually gets interpreted and converted into a low-level language while it's running, during runtime. All right, so I actually think that was like the most missed question on the exam, which is more just like you didn't study the notes very well, or something along those lines. The other one, which was surprising, I think the binary to decimal question was, most people got that right, but the binary to hexadecimal question, what was it? Was it? Oh no, it was decimal to hexadecimal question. Was missed quite a bit. So that's an area to practice. People got that skill didn't translate through with the two different patterns. So you might go back and study that, because all my exams throughout your entire career at Concordia are going to have conversion questions on them, and hex is pretty popular for programming. A couple other patterns I saw that are interesting to mention is I think like on a couple of the hexadecimal questions, folks just replied with like they memorized that conversion we did in class for the 2989 to hex. So my favorite hexadecimal number, BAD. So they just literally gave me that. They memorized that math. So that's not going to fly, and I definitely would not memorize the way of doing things by memorizing a specific answer. So probably not the best way to learn through that. So that was, two pretty heavily missed things. The other theme throughout the exam, which is also, I've been drilling this, is this concept of parameter passing to functions. Really trying to understand that if I'm expecting to take in some inputs. So for instance, this guy looks like a function. So let's say that this function requires 2 inputs. I will pass him 2 inputs. He will take in those 2 inputs as these names. And then inside the function, we will perform our logic on those inputs. A lot of people will have like take in inputs here, and then they start asking the user, like, please enter a numerator, doing an input thing, and or they just hard code numerator to something else. The purpose of writing a function is that we have a reusable chunk of code that we can pass these inputs to and generically work with whatever value is contained in numerator, whatever value is contained in denominator. And where this relates to a loosely typed language is nothing here absolutely enforces that these 2 values must be numerators. So good programming practice would say, name your values, your variables, very precisely to dictate the kind of value you're expecting. We know what fractions are, so we know that fractions expect a numeric numerator and a numeric denominator. So we should pass it a numeric numerator and numeric denominator, a numeric numerator and numeric denominator. But because Python doesn't enforce this, nothing prevents us from passing it a string numerator and a string denominator. As of right now, our code will work for this. But if you imagine we start trying to do math with this and cross multiplying hello times elephant, things are going to get error prone very quickly. Okay, so You know, so really drive that point home of
Quick question.
purpose of parameters. Go ahead.
If you were to like put a integer, like put int in front of the function, would that prevent strings from going into it?
No, because Python doesn't allow for that.
Okay.
Strongly typed languages like Java, C++, C#, they do. They require it, in fact. So that's kind of that differentiation between a loosely typed and a strongly typed language, as well as a interpreted versus a compiled language. You know, those two things, they kind of give you some information about how that language is going to behave. That make sense? You can ask some questions inside of here. So if you really wanted to police it, you could ask questions about the type of numerator and only do the logic if it was a int, and then you scream at the user if it's not. But you know, I would say that that's the best practice is to make sure your variable names are precise. They mean something. So like on the exam, I would, you know, for one of the questions, I named the variable that was coming in as list of numbers, because what was it expecting? It was expecting a list of numbers. And that particular question summed up all the values in there. So that was another one that was missed actually fairly often, is that folks were giving me examples of it just took in like the number 3. Well, it takes in a list of numbers, not just a number. So taking the length of 3 doesn't give you anything. It would give you errors and stuff like that. So the code tells you by the variable names what the kind of value likely is, because Python does not empower us to do that programmatically, whereas strongly typed languages do. Which is kind of why it is a little bit flip-flopped, in my opinion. I work with so many different languages, is that the perception is that these loosely typed languages like Python, like JavaScript, are easier languages for people, where I actually feel they're more difficult. There's less rules that kind of keep you in bounds, right? You know, if you're, you know, there's a greater chance of you if you're playing ice hockey, the ring around the ice keeps everybody inside. Doesn't matter how hard you hit that, you're not going into the audience. Well, I suppose if you hit it really hard, you go into the audience, but you get what I'm saying. We have those boundaries that keep everybody inside the ice rink, where at an NBA game, you just got a line on the floor, and you could step over that line and land in somebody's lap pretty easily. So Python would be more like a basketball court that, you know, you can have those boundaries by painting a little line or by naming your variable something very precisely, but nothing keeps you from jumping right over that and landing in somebody's lap at the game. Whereas a language like Java or C++ is going to be more like that ice rink, where you could try to jump into the audience, but you're going to be showing a pretty impressive level of athleticism to accomplish that. So, you know, I think that's a kind of an analogy where both of those things in real life are considered acceptable, but they do come with connotations, right? You know, in hockey, you probably don't necessarily sit there and worry about getting hit in the face with a puck, even though it's technically possible. But in basketball, if you're in the front row or, you know, within the first couple rows, getting hit with a basketball is you know, significantly more common, right? Same thing with baseball, that kind of stuff. All right, so Python does not give us the ability to define that. So as good programmers, we should name our variables appropriately to dictate it. All right, so this idea of functions taking in parameters and those parameters being what we should operate on generically was something that was heavily missed. Also, something I've harped on quite a bit, the difference between returning a value and printing a value. This print fraction guy right here, he prints a value out. This display function right here, he displays a fraction, as opposed to, maybe I have something in here called get fraction string. And what I can do is I can have him, I'll just steal the string from here. What, I have caps lock on? Oh, No, I am not hitting the shift key because I apparently don't know how to type today. So now I am returning a string that is representative of this fraction as opposed to printing that string. All right, these do different things. So if I come back down here and I say, let me get rid of the hello world thing here and this guy here. When I say F1.display, we saw that it printed out our fraction. When I said F1 dot, what was it called? Two fraction string? What do they call it? Get fraction string. Get fraction string, I get nothing there. He returns a value. And currently I'm not doing anything with that value. I can store that value as like, you know, my fraction string is equal to that. And again, if I run this, nothing prints out. But then if I go and I print my fraction string out here, I see that, oh, I did indeed capture the value that was returned by get fraction string. I captured it inside of this variable for me to do whatever I wanted with it. And what I chose to do with it is print it here. But I could have also, you know, concatenated, done some concatenation with it or something else. So understand the difference here, that this function displays a value. This function returns a value. They're both accomplishing important things that, you know, you want to use the right tool for the job. But those words, when I say write a function that does something and returns something, that implies you're going to have a return statement in there. You're going to be doing something and giving an answer back as a return, as opposed to if I say do something and then display the result, then you would likely have a print statement in there where you would do some logic and then ultimately print that. Okay, very important distinction. One is not better or worse than the other, but it does change the way that you would write the code, right? If I told you to go to the grocery store and buy some oranges and bring them back home, right, return the oranges, I would expect to get home and have oranges in the fridge. As opposed to if I told you to go to the grocery store and display the oranges, you would go to the grocery store, take a little selfie with the oranges, put the oranges back down and send me the picture. And I've seen the oranges now. So, you know, both of those are funny in their own right, but especially the second one. But the point is they are accomplishing different tasks. All right. So these are all kind of programming fundamental things that were missed fairly often on the exam that I think are pretty easy to, you know, kind of tie in. It seems like most people who have gotten the coding stuff to start to click now have handled the logic portion of things pretty well. One other thing that was missed at a reasonable level, I guess, was for a couple of things I said, write a function that does something, where you just gave me some code that does something. So out in here, if I say write a function that prints all the values, so print vals, maybe this guy takes this, well, here, we'll have him take a parameter. Starting val, ending val. And he goes through and says for I in range starting val to ending val, we'll just assume that it's not including that. We'll print I. Now when I call print vals 1 to 20, I get 1 to 19 printed out because it's non-inclusive on that second one. Where some people would have just written their code like this. Starting val is equal to 4, ending val is equal to 7. Actually, let's do 400 to 407. That way they're very distinct numbers. And then I'll go through all those. So now I have my 400 to 406 down here. This code right here is just code. There's nothing wrong with it, but it is not a function that performs this task. It is just some code that accomplishes something. So if the question said, write a function that takes two parameters representing the starting value and the ending value and prints all the numbers between the starting value and the ending value, I'm expecting you to give me a written function. If I never called that function, if I never did this here, that function has still been written, but it's an untapped resource. I never actually called upon it. That's okay. Nobody says you have to call upon your function. We think about objects here. We're likely going to write a whole bunch of stuff inside of fractions for fractions adding themselves to other fractions and things like that. Yet, in many cases, you may never use that function. Your smartphone has probably has an egg timer type thing in it. You may never have used it. I'm sure it has a compass and things like that that maybe you've never used. But or for you, whatever that feature is, your phone has 10 zillion things it knows how to do. I'm sure some of them you've never happen to need, but it's still there if you want to. Okay, so these are kind of programming fundamentals that we want to keep an eye on and practice. So to kind of just finish up this introduction to classes, so we're ready for the second 8 weeks. Classes are made up of fields, constructors, and functions. The field is our variables associated with the a class, like numerator and denominator. The constructor is always going to be that init function, underscore init. And that guy will initialize those things. And then the functions are the things that it does. Okay? Questions, comments, concerns, bribes. Let's see how many people we ended up with here. Well, we only have 27 left. We dropped a couple during class. All right, so make sure you tell your friends from class that everybody's expected to be on the Zoom meetings and things like that. The next time I will see you is the Monday following break, so that's a week from this coming Monday. But I am around during break if you want to get on a Zoom chat or something and work on some stuff, or if you want to get your study group stuff set up. Feel free, just send me a message and we'll get that set up. Otherwise, check Slack often, check email often, make sure you follow up with your other teachers, and stay in touch, and everybody be safe. All right, I will see you when I digitally see you.
Bye.
Have a good one.
Yep, you too.